Okay, what I want to go over is the second part of that video on reaction types, specifically honing in on double replacement reactions. That's where it gets complicated, or at least I shouldn't say complicated, more detailed anyway. Okay, so let's go ahead and jump on that. Okay. Just a quick review on a double replacement reaction. Double replacement reactions are when we have two ionic solutions and you know that from the AQ, are mixed together, we end up swapping the anions. In other words, these two get swapped, the nitrate and the chloride. So now we have a new common set of combinations. We have sodium and the nitrate, the new combination, and the silver and the chloride, new combination. Okay, so then you have to analyze whether the new combinations excuse me, are soluble or insoluble. If they're insoluble, they'll form a gas, liquid, or solid. So notice here, there's an S there, meaning that when we look at the combination of silver plus chloride, it's a solid. Okay, now you can tell that on our solubility table, because you've got chloride and sulfur, black. That means it's a solid. Okay, so there are three kinds of equations when we write a double reaction, a double replacement reaction. There's the molecular equation, ionic equation, and the net ionic equation. TIE for total ionic equation. Net ionic equation, and then there's the molecular equation. Okay, now this is only written if you get a SLG over here. Okay, if you don't get a solid liquid gas forming, then it is a null net ionic equation. In other words, no net ionic equation. The total ionic equation pulls apart the two solutions in its cation and anions, cations and anions, and lists them separately. Now, we have to always balance these equations too. So is this thing balanced? Well, we have one sodium, one chloride, one silver, one nitrate. So that's balanced as written. One chloride, one silver. Normally these are reverse, because I always write the cation first, just like over here. And we have one silver and one chloride, so that's balanced as well. Now, there's a lot of little parts here you have to pay attention to. Make sure you have the status. Is it aqueous? Is it a solid? Is it a liquid or gas? That has to be specified per ion. Also, the charges need to be specified as well. Now notice there's no charges in the solid, only if it's aqueous. Okay. So let's look at this guy here. All right, so we have lead nitrate, aqueous. Why is it aqueous? Because nitrates are all white, all the way across. That means nitrates don't form a solid with anything. Okay. Sodium. Same with sodium. So sodium anything, potassium anything, nitrate anything. Excuse me, those are always soluble. They are always aqueous. Okay, so let's look at this now. So we have two solutions, aqueous, aqueous. That means it's a double replacement. Number two is we're going to swap the anions. Okay, what happens when we swap the anions? Well, the Br goes over, the bromine goes over to the lead, the nitrate goes over to the sodium. So we have sodium nitrate. We already know, I just mentioned that that's going to be aqueous. What about lead bromide? Okay, now let's go over here. And here's Br. And here's lead. And notice it's black, so that's going to be a solid then. Okay, the next question is, we're going to write the three equations. The first equation is going to be the molecular equation. Okay, that's where we have no ions shown. Okay, so we have lead, and that's a +2. Nitrate is a -1. Sodium is a -1. Br, excuse me, +1. Bromide is a -1. Okay, so we need 2 nitrates for each lead. So when we balance this, we need 2 bromines here. It means the coefficient here has to be 2. That kicks the sodium up to 2. And then we have 2 nitrates, which are here. So that's balanced now. Okay, we always have to balance equations. Now, so that is the molecular equation. The total ionic equation is going to be lead +2 aqueous +2 nitrates aqueous +2 sodium aqueous +2 bromide aqueous. Okay. Total ionic equation. Now, the S's solids mean that's together. We're not going to, it's not going to be in solution. So that's PbBr2s plus 2 sodium aqueous plus 2 nitrate aqueous. So that whole thing with all those little parts is the total ionic equation. The net ionic equation is all we're looking for is how did we create the solid? We created it from 1 lead plus 2 aqueous and 2 bromide aqueous. Now, are there ions left over in aqueous that did not participate in the reaction? Yes, those are called spectator ions. That would be the sodium and the nitrate. They stayed in solution. Okay, let's look at this. We have aluminum sulfate, calcium acetate. Okay, now, does anything happen when we mix those two together? Solubility table. Okay, so we're going to swap the anions. So the sulfate and the acetate get swapped. So we end up with, excuse me again, aluminum acetate, calcium sulfate. Okay, so we have acetate and aluminum. And soluble, no solid, white, okay? And what about calcium sulfate, CaSO4, okay? SO4, calcium, black. It means it forms a solid. So that's the molecular equation. Okay. Now we have to balance the molecular equation. Okay. So we need a 3 here because there are 3 sulfates, 3 sulfates, 3 calciums, 3 calciums, 2 aluminums, 2 aluminums, 3 sulfates, 3 sulfates, 6 acetates, 6 acetates, so it's balanced. Okay, now the net ionic equation, we pull these, can pull these apart. So the aluminums, we have 2 aluminums. And those are +3. If you look on the solubility chart, you'll see that. And it's aqueous. We have 3 sulfates. 3 sulfates, and those are aqueous. 3 calciums, 3 calciums. 6 acetates. Because this is a and because this is aqueous, it's aqueous based on our solubility chart. Okay. And if we're doing the net ionic equation, this is the total ionic equation. If we're doing the net ionic equation, what made the solid? Well, calcium and sulfate. So the spectator ions were the aluminum and acetate. Okay, let's do, now I gave you an additional worksheet with quite a few practices on there. Now I want to emphasize that these are going to be covered in your final. Okay, so make sure you understand these. You're going to be covered less in detail on your exam 4, but in lots of detail on your final. So between the two, studying for your final and studying for this test, make sure you get these down, particularly lecture 1 on reaction types. You need to identify, is this a double replacement reaction, single replacement reaction, a synthesis or combination, or a decomposition. Okay, so that's the main thing I wanted to cover. Now we can do the same thing when you make water. The water is not going to be covered on the solubility chart, because the solubility chart is looking at ionic solids. Okay, a molecular compound is not ionic, so it's not going to be on the ionic solubility chart. Okay, so this time you're looking for things like water, a gas. Usually those are the two main ones. Okay, all right. So let's do another one of these ionic ones here. Let's look at, let's see. let's take lead nitrate and potassium chloride. Okay, so number one, this is a double replacement reaction. Why? Because we're taking two ionic solutions together. We know it's ionic because of the AQ. Okay, so when we mix these together, we swap the anions. So that means the lead is with the chloride now, the potassium is with the nitrate. Okay. So do either of these new combinations produce a solid? Okay. So let's look at lead and chloride. Okay, here's lead. And there's chloride. So chloride, if we come across so that's black, that means it's a solid. Potassium, you already mentioned. It's white all the way down, so it doesn't form a solid with anything. So that means that's going to be aqueous. Okay. Now, is this balanced? Well, let's look. Okay, so we have one potassium, two chlorides, one chloride. I have to make, okay, so we're going to go, so that gives us two chlorides. That makes the potassium 2, so we put a 2 there. Okay, two nitrates, one lead. So if we just list these, lead, potassium, chloride, and nitrate, we have 1 and 1, 2 and 2, 2 and 2, 2 and 2. Okay, so that is the molecular equation. The total ionic equation is we pull everything apart. So now we have lead aqueous plus 2 nitrates plus 2 potassiums plus 2 chlorides, yielding lead chloride solid plus 2 potassiums and 2 nitrates. So that's the total ionic equation. The net ionic equation, did we produce a solid, liquid, or gas? Yes. We made lead chloride solid. And how do we make that? We made it with the lead. We made it with the chlorides. And that's the net ionic equation. Spectator ions are the ones that appear on both sides of the equation that didn't do anything. That would be the nitrate and the potassium.